Good morning everyone. Today we're going to do a live coding demo of how to show a rainbow on the NeoPixels from the S4A Arduino Elements Silver box. Okay, so first of all we're going to open up S4A Arduino and we'll get in a blank project. So just open up your folder where you've got S4A Arduino probably on your desktop here. And if we just click right in here first of all and open up a project. So this is just like a blank project, and then we'll probably clear out some comments and stuff like that to clean it up a little bit, and I'll show you the hardware. Here we can see the hardware, really simple. We're just taking a NeoPixel strip, plugged in a Grove connector, and I've popped it into the shields, plugged into D4. You may have a nano shield, which is a bit smaller, in which case you might need to adjust the instructions here a little bit, but it should be fairly straightforward to work it out. I picked pin 4 at random. There's nothing special about it. Any of the pins can drive the NeoPixels. The protocol doesn't require the analog write or pulse width modulation pins to use. Okay, so we'll go back to the code and I'll show you how it works. Okay, now we'll start making the code. So first thing we'll probably do is we can trim out some of these comments because we already know really where everything's going to go. So we'll just clean that right up here. And next thing we want to do is we want to go to the snippets window. Now if you've seen the snippets before, this is where you can just really easily pull code, drag and drop it in. So look, here I'm dragging in something to set the pin mode for output. We already know that pin 4 is going to be the pin that drives the NeoPixels. So we'll set that to output mode because it's going to need to send out signals. And it's just really as easy as that. You just drag stuff in and drop it. Now you can see that we've already got some NeoPixel stuff down here, some basic NeoPixels that comes with S4A Arduino in the Swift AVI library, but that's not really going to be as useful as that. It's nice to have a little bit of code wrapped around that. So what we're going to do, we're going to access the libraries from the open source community. So there's an open source community on GitHub. You can download them really quickly like this from the advanced menu as I'm showing here. This will keep a copy of them. It'll just put a copy locally on your file drive in your documents folder, documents S4A Arduino. If you look down here, documents S4A Arduino, you can see them in there in community. These are just simple Swift files being contributed by people from the community. Obviously I've written most of them at the moment, but you know, more and more people will be adding them. And to add them into your project, you just go in here and you tick the ones you want to add. So today we're going to be adding the iLED helpers. iLED is what we're calling the NeoPixels. NeoPixels is technically a trademark. So intelligent LEDs. And then when you click done on that, one other nice thing is that you'll see it's automatically brought in a whole load of useful snippets that you can use. So we're going to use one of these right now to set up a NeoPixel buffer. So the buffered version of the NeoPixel is it like keeps 10 values or however many pixels you've got in memory. And there's a few things that we're going to need to set here. So you can see the parameters that it takes here for the buffer, the pin that the NeoPixel signal goes out on, the number of pixels, and has white chip, true or false. So NeoPixels come in various different varieties. Actually, let's just tidy this up a bit. Let's use this. So we've got this constant here saying pin 4, which is where the NeoPixel is. So let's just be good programmers. We'll drag the pin mode setting down here and we'll use this constant so that if we ever need to change the sketch around, the program around, and use a different pin, then we can, and it's really straightforward. Just change it in one place. So this is very important here, the number of pixels. It'll always be 10 for the S4A Elements box because you have a 10 NeoPixel strip. And that's fed in here, but the other thing we need to change here is has white chip. So some NeoPixels have a white LED as well as the 3 RGB LEDs. The NeoPixels that come in the S4A Elements box don't, they're just straightforward RGB LEDs. So we're going to need to go and change this has white chip value to false. And because this is general code that's being used for all NeoPixels, but we'll just have to adjust it here for the S4A Silver Elements Silver box. So once I've changed that, the next thing we want to do is pull something in to draw a rainbow. Now that you've got a buffer here where you can set values, so you can set like buffer 0, buffer 1, etc. you'll see in this code that we drag in here, this is just a nice sample snippet of generating a rainbow using the buffer. So if we drag that right in, put it, let's see, just put it up here. You can see we're using the iLED fast make color function, and this produces colors that we're going to put into our buffer. So you're iterating over the 10 pixels of the buffer, and we're creating different colors for each one. And the way we're doing that, we're using a hue saturation value, and we're just adjusting the hue smoothly over the 10 pixels. You could use RGB under other circumstances. You can see documentation of these in the documentation folder, which is down the bottom here. So just have a quick look at that. You can see this is how we're setting the buffer. And you have to be fairly careful to use this exact syntax. And the most important bit at the end of it is once you've set all the buffer values, that's just in RAM. So you call this function here, and that actually streams it down to the NeoPixel and sends the signal down. And then lastly, we just call rainbow to set it up. So we'll upload that. Oh, okay. First of all, we're going to need to save it. So let's just find something to save the program. And call it something appropriate. Rainbow test, that should do. Okay, now we'll press upload. And let's go and have a look at that. Okay, so we pull back, have a look. Yeah, that's really bright. You almost need to, if I zoom in on that, we'll see if we can get the color balance down. It's just so bright you almost can't see it. It's saturated out. This is the thing about NeoPixels, but if I bring it up, you can see we've got a beautiful rainbow there. And this is just literally doing hue values across the spectrum, starting from the right to the left, starting from pin 0 or NeoPixel 0 on the right, going through to NeoPixel 10 on the left hand side there. Yeah, and it's really just as simple as that. Okay, now if we go back to the code, I'll show you how to make that roll. Okay, so we're back in our code here. Now we've got another nice little snippet here, which is roll buffer. So this is really a very straightforward function. Anyone who's familiar with Swift can see how this works. You're basically just taking out the first pixel, and then you're iterating through all the pixels and moving one pixel down into the next throughout the buffer. And remember, you're just manipulating RAM at this point. And then at the end of the and then you kind of roll it around. At the end of the function, you write it out to the NeoPixels with an iLED fast write buffer. So we'll do a call here in the while loop to roll the buffer, and then we'll put in a delay in here. So we're just going to roll it regularly. So let's try. First of all, let's try 10 milliseconds. See how that looks. We'll upload that. See how it looks on the hardware. Okay, here we go. See, that's a little bit too fast to see, so let's just go back and slow it down a bit. Here we set it to 50 milliseconds, and you can see that's much easier to see, much more pretty. Lovely rolling rainbow effect. And all of this is just using standard Swift for Arduino out of the box, and this code from the community website, which is open source Swift code for Swift for Arduino. Get coding by Swift for Arduino S4A Elements Silver box right now, and you could be up and running and writing beautiful rainbows like this within minutes.